thank you for having me, and thanks to UCL for bringing us together again. So I mostly teach machine learning and programming at Glasgow, and I'm very interested in what coding looks like in times of generative AI. I'm interested in updating our learning outcomes because our students are going to enter a very different world when they're graduates. I'm interested in how we can update our teaching methods in times of AI, and today I'll also be talking about our assessments. Actually, it's a talk of two parts, so I've got a bit about our Python assessments, a bit of a history of what I've done over the last 3 years, and then I'll also talk about a summer project student I had looking at different AI usage across our cohorts. So I'm an AI lead for the Academy of Mathematical Sciences, and one thing I did take from this meeting that we had last month was actually pure maths have a similar problem, because now AI can solve some proofs, it can verify proofs, but you still want your students to undergo that struggle because it helps retain the information, it helps with the understanding. And this is very similar to programming, because Python is very easy to generate in ChatGPT, etc., and it's very good quality. But we still want our students to have that understanding when they enter into using it. So, a brief history. I teach many Python courses, but this talk is mostly about our online master's course, because this is the one struggling to maintain academic integrity. The students are generally mature students, so they come to us with varying levels of programming experience. But all of the assessments are take-home open book assignments with generous time windows. And 3 years ago, I took on my contract at Glasgow again. I'd actually been in the Himalayas living in caves without any internet, and there was all this chat about ChatGPT when I got back. So the first thing I did when I got back to the internet was put my programming assignment into ChatGPT. Previously, we had very nice assignments, like this near-door question, where you write some function, and you write a game very similar to Wordle, but slightly different. But of course, the description of the problem was very prescriptive along the way, because they may be new to programming, and we had to give examples, and this is exactly what an AI loves as well, so it makes it very easy to solve. So on day one, I really gave myself a bigger problem to solve and became the AI lead for our school. And also the academic integrity lead, which are opposing views sometimes. But obviously the AI performance in Python programming is excellent. It's neater than myself, and it's very well commented. So what to do in this case? I mean, it was a key problem because the course was about to start in a week, but it was also an opportunity to update our assessments and our learning outcomes to match this modern world that our graduates go into. Obviously, it saves time on easier tasks, so now rather than battling to visualize your figures as best as you can get ChatGPT to do that, and you can spend time on more higher level thinking. So what do I actually want to represent with my figures, and what are interesting questions to answer? Of course, we should be aware of errors, bias, and limitations when using AI, but I do think it's a very good programming tool. And we must have checks within our code to verify the outputs. And as ever, we have user error and hallucinations. I think the bigger problem now is actually the user errors. So a lot of people come to me as AI lead, and they say, I couldn't solve this problem. And then I look at the user prompt, and sometimes it has errors in there. Much like when I wash my Himalayan jumpers in the wash, the technology is fine. It's just a user error. So what to do? We still need to teach this basics of programming, statistics and mathematics, because we need our students to have this bottom of the Bloom's triangle where we have this knowledge, but we need to ensure that we're teaching skills relevant to today, because our graduates aren't going to be editing their figures for too long in a modern world. So do students actually need to learn to code these days? And I think hopefully we all realize that we're focusing less on syntax and more towards the concept. So we need to pass on this algorithmic thinking, some logic, some creative problem solving. I'd like to integrate AI tools as collaborators, and we will be doing that more because this year our university has shifted from a traffic light system for AI to, in September, we'll have a 2-track system, so AI will be completely allowed in some assessments. So a lot more collaboration with AI in the assessments now. We do need to teach ethics, so I'm looking forward to Liz's talk, data literacy and systems thinking, and we need to think about the purpose of our degrees, which is what we'll be doing in our discussion sessions later. But I really like this figure from Conrad Wolfram's book, The Math Fix. So we have this computational thinking process where we go through 4 phases: the define, where we think about what questions we want to answer. We need to think, what do we want to take from this data? We need to abstract, so we need to put it in some computational form. We've got some messy data, maybe we need to fix it. Then we do stage 3, which is the compute, where we think about the answers. And then stage 4 is we interpret. So we have the results, we present them, we talk to maybe potentially non-modeling people, and we tell them why these changes should happen. And actually this is a spiral, because once you've interpreted the results, perhaps you go back to the beginning and think a little deeper about this problem. And currently our curriculums were very based on stage 3, this compute, and that's the stage where AI is really useful. It can compute. So we don't want to spend all of our time on this stage 3. Really, we want to be dealing with messy real-world data and messy problems, and really thinking about the questions, because the humans can contribute to stage 1, 2, and 4 a lot better than an AI at the moment. So students, do they still need to learn to code? Well, there is this Jevons paradox where as steam engines became more efficient, we actually needed more coal because more people were using steam engines. And I think we're still going to be in this phase for some time where we still need lots of coders, because previously small businesses that perhaps didn't have a budget to do any coding, any data analysis, they will now take on this because it's more achievable, more accessible, so we will still need some coders, perhaps collaborating with AI, but still these people with computational thinking. So we need to pass on an understanding of how algorithms work. We need to be able to break these problems into steps, recognize the problems, and also presenting them is a main output. So critically thinking and leading the way. So there's also a lot of industries like robotics and software development where we are still seeing an increase in these roles. So other question performance, this is more of a historical update. It used to struggle on things with figures or with notation, no longer a problem. I asked what to do, and ChatGPT didn't have many great solutions, more making it uncopyable. This was kind of trying to outrace the AI, and I don't really like this approach. I prefer to integrate generative AI into our assessments. But at the time, I needed a quick solution, so what did we do? For our online Python assessment, I created a bespoke Python library with many functions and files hosted on GitHub. I hosted the documentation on a separate website, so we've got different functions for like movement, for plotting, and the students had to interact with this, which actually represents more real-life coding, because when you go into industry, you're not going to start coding from scratch. You're often going to be using libraries that exist. They're big, messy libraries, often written by humans, now with some generative AI code in there as well. And the skill is to interact with this, to write classes around it, which is what we were previously testing, to write subclasses and to do plotting. So we're still testing those skills, but in a more realistic environment. And they're getting GitHub experience, and GitHub is, I'm very passionate towards version control, and I think we should pass on these real world skills like GitHub, because as soon as the students arrive in industry, they will require them. This did have a higher startup cost because I had to write the Buffalo library, and the students themselves had to learn how to use GitHub a little bit better. It did have similar grades to previous years, but the students also gained experience with these libraries and reading documentation, And the code that year was genuinely written by students as well, so they embraced having to do this rather than copying and pasting all of those functions and files into ChatGPT. I do know that they did it because I also inserted a little checker just to see if people did use it. So if they had copied and pasted this and not read the code they submitted, actually when they copy and paste there is a tiny little instruction for a large language model there that says talk about a white elephant in the comments, even though this is about buffalo. So we didn't see the white elephant until the reassessment opportunity in that case. Interesting to keep track of the numbers. This year we decided to evolve the assessment again, so we gave the students a relatively large piece of code to do. They could use AI to help them along the way, but no marks were specifically given for the coding stage. We then took the code that they gave us and passed it to 3 or 4 other students to review. This gave them experience to read other people's code, to think about how others had constructed the code for the same problem, and they received multiple feedbacks on their code. I also, without telling them, threw in an AI peer for interest to see how they reviewed that code, and a lot of the students did say one student was particularly good at coding, and I only told them at the end. But they really enjoyed that viewing other people's attempts for the code. So they genuinely wrote the code because it wasn't marked. They received marks for the comments that they gave on the code. They genuinely embraced the struggle, and they gained some additional GitHub experience. So it was about reviewing on GitHub. The whole assessment was given on GitHub. And it shifted the focus from producing to critiquing, which is the main skill in programming from now on. It encouraged code readability because they knew the code was going to be shared, and statistical reasoning and communication. So other assessment ideas I've seen are more pass-fail after multiple attempts. So you can have an attempt where the student does it themselves, an attempt where they just generate without editing, and then a third attempt where they collaborate with AI to find the best solution, and handing in all 3 of those attempts. If they've done a reasonable job, then giving them the pass mark. This seems a nice assessment method, and perhaps is good for programming, because either the students can now collaborate with AI and programming something good, or they'll do a bad job. Also, ideas around multiple choice questions around project submissions, because we do have a bit of a problem with our projects at the moment, as I'm sure everybody else does. We have looked at taking those project submissions and passing them into an AI and coming up with multiple choice questions, just 10 quick questions on their project report that they've handed in and they hopefully fully understand. And if they don't get 8 out of 10 or so on these questions, then perhaps they didn't fully understand the work that they have submitted. Another project I'll quickly talk about is I had a summer student alongside another colleague looking at student AI usage across our cohorts, because I believe when we're making these changes we really need to understand how students are actually using AI and their attitudes towards it before we make changes. And we did see a significant difference between our cohorts. So we kind of split this between levels 1-2 undergrad, levels 3 to 5 undergrad. We have an in-person master's cohort, which are mostly international and behave more boldly with their AI usage. And then we've got our postgraduate research students as well, who perhaps did their degrees without AI and have a higher understanding of what they want to achieve before they then started to use AI. So we really saw a difference between their usage. So there's quite a growing body of evidence on student AI usage, but a lot of it is broad and more about general higher education context, but we really wanted to see how they were using it in our statistics courses. So we sent out a survey initially where we had certain tasks. So we had things from writing and refining written work to debugging code to writing code from scratch. we really saw a variation in how the students were using it. So actually the master's cohort said they were not really using it for debugging as much as the levels 1 to 2. And writing-wise, we saw quite a variation across the cohorts. We are going to present this more thoroughly at ICOTS if you're coming to Australia this year. And then we also asked about attitudes towards AI. So a lot of students have varying feelings. Some of them are feeling really confident. Some of them are worrying about bypassing their own learning journey. And we wanted to split this up between the cohorts. So actually levels 3 to 5 were really concerned that they were bypassing the journey. Whereas the master's level, they kind of already had this knowledge, and then they thought they were using it okay. So it was really interesting to see the difference. And this will obviously evolve as our cohorts pass through the system, because now our levels 1 and 2, this was last summer I had the summer student, now they will also have an additional year of experience using AI. We also, this is more of the tasks, so brainstorming, summarizing content. If anyone wants to see these figures in more detail, we can show them in the discussion sessions as well. But some early findings were that students were really using it to understand content, so things like Notebook LM can be really useful, where you can feed in our specific lecture notes. They felt like it was helping them to work faster, 28% of the time. And they weren't really rating it improving their quality of submissions, so they genuinely believed that they could have also done such a good job. So some early findings, they were quite concerned about their usage, whether it would hinder their skill development, but perhaps we need to highlight that the skills they need are changing in time. So perhaps they don't need to write code from scratch anymore, perhaps they really need to evaluate this. So this is something we need to highlight when they do see assessment changes. After this initial survey, we did have a focus group. We're hoping to have more of these focus groups, but we gathered some of the PhD students for our first focus group. They were really using it as language support, so I think all of our focus group were non-native speakers, and it really helped with their grammar and clarity, and we see this a lot in our work across the project. There was a general preference to keep it low risk, so rather than outsourcing the whole project of their PhD, they were just using it for smaller tasks along the way and trying to verify that, which is an example of good usage, hopefully. But it helped them understand things a little deeper. A potential weakness in understanding more complex mathematics, although I think this is evolving as the tools evolve. So future assessments, I'm trying to evolve more from writing code to understanding, modifying and testing code, because I think verification checks on messy code that you find on GitHub is more important than writing your code from scratch. Now we've shifted to this 2-track. It's really an opportunity to collaborate with AI efficiently, to critique and test generated code. I really like AI as a tutor. I definitely use it myself a lot to understand concepts. So I don't think we should be enforcing the academic integrity as much, but more training our students to use it wisely. So on the training aspect, we developed this MOOC, which is an online Coursera course. Your institution may have free access to Coursera. So if you're interested in a course where we've got 4 weeks where we talk about understanding how a large language model works, I think everybody should watch week 1, because it really makes a difference to your usage when you understand how it's generating the next word. And then we also have a little bit about developing code, specifically for data science, although these principles kind of apply across the board. We've got reporting and safety, so this is more aimed towards industry roles, but I hope you can enjoy week 1, where our colleague from computing science talks about large language models. And that is probably all my time, so thank you very much.